Hey builders, in this video, I'm going to take a look at an older AWS architecture and see how it's withstood the test of time. We're going to align it to the AWS Well-Architected Framework and see if there's any tweaks that we would make now. In this video, we're going to be reacting to a design from Netflix around multi-regional resiliency from way back in 2017. Let's take a look. So right out of the gate, we've got a brand new intro to the video, which is not surprising. This is, I think, the second or third, it's under 10 of the This Is My Architecture series. So they're still tweaking the look and feel.
Welcome to This Is My Architecture. Today I'm joined by Coburn from Netflix. G'day, Coburn.
Hey, hello.
Thanks for joining me today. Now, you guys do some pretty cool stuff. I love sitting at home with the family watching Netflix all the time.
Awesome.
So here we get the quick intro. If you don't know who Netflix is, I don't even know how you found this video. Obviously, we all know who Netflix are. They're a massive AWS customer, and they have a really, really cool design and have evolved it over the years around resiliency. They've published a whole bunch of great open source tools to help all of us deal with the realities of cloud. In this one, they're going to specifically be talking about how they're handling DNS. Now, we all know when anything goes wrong, it's always DNS because DNS is a pain in the you-know-what to troubleshoot. Let's see what Netflix has to say about it.
For resilience, for globalness. Now, I'm wearing the Chaos Monkey t-shirt here.
I like it.
What do you guys do when the monkeys get loose? Talk to us.
So Chaos Monkey is a service within the Simian Army, a great set of tools from Netflix. And in fact, at this point now, a few years later, so this was 2017, now in 2021, AWS actually has its own chaos engineering service, and we're seeing a lot more formalization around chaos engineering, which is definitely worth checking out if you haven't already. It's basically the idea that you are going to test out your architecture and see what happens when things randomly go offline. Is it resilient enough? Is it reliable enough? And this is really the tone of the video. We're going to be focusing a lot on the reliability pillar of the AWS Well-Architected Framework, whether they know it or not.
That's some cool stuff you've been doing.
That's right, yeah. When we have the big monkey unleashed, which means we have to evacuate a region, we have a relatively complex failover model, but it's
Okay, so we're talking specifically about when a region goes down or they have to get out of a region for some reason, how they handle failover. So this is a really rare event. We haven't seen an entire region go down in AWS in quite a while. And when it does, it's normally one or two services in a region. But in this case, what they're saying is, okay, from our resiliency model, from our reliability model, if one region, if US East 1 goes off the map, what do we do? How do we handle that?
bunch of principles in the architecture where we try to simplify various dimensions, whether it's scaling or DNS, and that's what I was going to talk to you about today.
Let's dive right in. Got something cool here.
Yeah, so when we think about, the tens of millions of devices active at a given time, and they're trying to talk into Netflix, we simplify the model with very high-level DNS record.
Okay, so all the Netflix devices and software that talk to Netflix, they don't know about the subdomains here. They just go to API-global, which totally makes sense because then that will route them to wherever they need to go.
And then we apply geo-routing that lets these individuals route to regions that are latency or for other reasons ideal for them, right?
So geo-routing is a core piece of Amazon Route 53. It was in the beginning and it still is today.
What we've done is we've leveraged Route 53, but at this level we have what we call virtual records. So you have our top level DNS record going down to what we call a virtual record. And this is where we steer traffic to in a geo manner. Below that we have the actual origin records, where people are going to talk to in the end, and those origin records are bound to ELBs. And we have
Okay, so they put in a layer, an abstraction layer in between the major primary API global and then the actual origin, which is in front or attached to the device that's actually responding to the request. They've done that through what they're calling a virtual record. And I imagine that's because they can play around with that a lot easier and avoid DNS caching and DNS timeouts.
maybe 50 distinct ELBs, and those farms themselves might be many hundreds of instances. In the process of doing failover, we have to differentially steer people around to avoid overloading the target region before it's scaled up.
Okay, so critical point there that a lot of us don't necessarily have, but you should still consider, is that when they are doing failover, what they want to avoid is, if everything's coming into this side, completely just slamming this side. They want to do a gradual failover, and in their case, they've got multiple areas that they're failing into. They want to make sure that they're doing that in an intelligent manner instead of just absolutely turning the tap from A to B.
Banging a whole region's workload on another one, basically cascading the failure.
It would just, and we have to actually route some traffic in different ways.
So sums it up nicely if they didn't account for this problem.
Virginia, part of it goes to Oregon, part of it goes to Dublin, right? So what we've used is within Route 53, one thing that's very important to us is the ability to quickly change these records for possibly hundreds of endpoints for devices. One of the benefits of Route 53 for us is we decouple the virtual from the origin. And the capability of Route 53 that's of greatest value to us is the support of many different types of alias records within your zone.
Okay, so the virtual record that they're referring to is actually a collection of alias records. And the reason being there is that DNS handles different types of records in different ways. And the idea is so that if your device is making a request to, say, google.com, that every single time it makes a request, it doesn't actually go and say, hey, where does google.com live? Oh, it's at 1234, I'll go there. So there's caching structures in place, and different record types cache at different levels, and you can customize that and tune that. But then the device itself sometimes overrides those requests. But what they've got here with these alias records is that they're able to actually switch those programmatically, and they shouldn't be cached. They should be able to change that alias quite quickly. Let's see how they're actually using it.
So when we fail over the region in a steady state, you have traffic coming here in your normal pattern and routing down to their origin, and then routing down to the ELBs below that in some
So this is the normal pattern. This is when things are working good.
way, right? And when it's time to fail over, our flow architecture
Ooh, fancy animation.
actually starts to rebalance capacity, and then at some point it actually goes in, repoints this record within Route 53 over to here.
So most of our viewers will be going,
There we go. Okay, so that's what they're using the aliases for, is they're actually, when they get to a certain point where they're confident enough in that new route, they're going to go in and change programmatically that alias record to point to the new origin.
aha, but what about TTL?
That's right. So one of the big benefits of Route 53 is that broad support of alias records, right? So alias records have two primary benefits for us. One is it lets us chain many sort of names together, and it avoids recursive queries. Without that, with many DNS providers, you're required to fall back on CNAMEs.
So there's the key, one key for the alias records is that they can chain them, right? So you can link alias 1 to 2 to 3 to 4, and it'll fall through. And the way those alias records are handled is intelligent, and that won't set up a recursion. And for CNAMEs, they're handled differently, so that you actually can't link it in that manner, even though it looks like you can. The way that those records are processed will not achieve the goals that they're looking for here.
CNAMEs put a lot more work on the DNS infrastructure, and as well, they have TTLs for every level. As you can imagine, we have many tens of thousands of devices that all treat TTL differently.
So TTL's time to live, and that's the key he just hit on, was that devices treated all differently. You have TTL at every different layer. That doesn't apply with alias records.
By being able to apply alias records, we have high-level TTLs somewhere up the stack, which are honored quite well. But below the level, we don't have to worry about that.
You can change all that behavior.
Exactly.
So that's really the key, is that if something isn't sitting there with an expectation that what I know exists at google.com will be there for the next day or 5 days, it will constantly check on the request. So it makes a new request. It goes, okay, it was an alias. I'm going to check again, which allows Netflix to change things around in the back end to accommodate these failures.
In a matter of minutes, we flip over to another region. And then when it's time to fail back, we don't have to maintain the state. Our architecture will actually go in and interrogate where the pointer is. So even if something goes wrong and we have to take longer, something might be changing in the rest of the state of the system. We just say, oh, it turns out the state we're in right now is we're sending traffic from US West 2 to US East 1, and we just do a repointer program.
Interesting. So they're taking advantage of that as well on the way back, is that because they're using the alias records to do this, they can actually take piece by piece and move them back as required as things get back to normal, or if they need to make another adjustment. It's not an all or nothing. And I think that's critical to this kind of resiliency, this kind of reliability, is they haven't set it up so that we're in state A or B. They can be in all sorts of mixed states and things will work perfectly fine, assuming you program the back end to match this. But aligning the requests to something that can serve that request is actually a really hard problem. This is a very clever solution.
So it's kind of a real-time state because you can handle whatever situation you're in. You don't have to kind of get it all nicely organized again.
I just said that.
Right. And when we run in our failover model, we have services running in each region, and the regions we're evacuating to are working in coordination and managing these independently, saying, I'm now ready, bring that traffic to me.
So it's a pool model of traffic.
That's right. It's understanding how to flip it programmatically all from within the same service.
So quite a few key terms in there. Pull model, so that the services are saying, I'm ready now, I'm going to take traffic on, as opposed to stuff being pushed to them. But also everything being programmatic is key, because it means it's not up to the humans to make the decisions. They've already made those decisions ahead of time of like, here's the structure, here's the if-thens, and then the system is taking care of it.
So we're talking intelligent traffic steering, we're talking about understanding the failure conditioning that's taking place and maintaining a streaming experience, to me, sitting at home in Melbourne.
That's right, absolutely.
I like it, Coburn. Sensational solution. Thanks for sharing.
Yeah.
Okay, so that was a really cool solution, and I pretty much guarantee that this is the same thing that's in place today. DNS is really long-lived. Obviously, it's a core piece of the internet infrastructure, but the way that they're leveraging alias records is really interesting, and they're working to their advantage to make sure that they don't have to make a decision of A versus B when it comes to failover and to resiliency and reliability. They've got this flexibility on a per-service level of where they want to route stuff. So theoretically, if every other region went down and they could scale big enough up in one region, they could route all that traffic to one region, or they could make sure they're distributing things to every region. This is a really clever solution using a relatively simple construct, which is normally the sweet spot when it comes to architectures, because it's conceptually simple, it's pretty straightforward to verify, it's resilient across, because Route 53 is a phenomenal SLA, and is quite simple to understand, and they're avoiding some of those pitfalls of DNS. Kudos Netflix. I don't know if we're going to hit many of these in doing these retro reacts, but this is something that probably hasn't changed a bit. Maybe the scripting as far as making some of the decisions has changed, but the core idea of the solution, leveraging those alias records to avoid time to live pitfalls, to route traffic intelligently, is still probably working today. And it's something I would highly recommend that you leverage if you're in this kind of scenario where you need to have a very diverse failover scenario across different assets. Kudos Netflix, and we'll see you in the next video.